Question number 18. A motorcyclist as a particle is undergoing vertical circles inside a sphere of death. The speed of the motorcycle varies between 6 meter per second and 10 meter per second. Calculate diameter of the sphere of death. How much minimum values are possible for these two speeds? Now, we will write here solution. In that given, a motorcyclist as a particle is undergoing vertical circles inside a sphere of death. Suppose we consider this is the sphere of death, and in this there is a vertical circular motion. Then we have given two speeds at lowest point. Suppose here VL is the speed and here VH is the speed. Then you have given VL is equal to 10 meter per second and VL VH is equal to 6 meter per second and VL is equal to 10 meter per second. Then we have to calculate diameter D equal to, and also minimum values of speeds, that means VL minimum and VH minimum. See here we will use the law of conservation of energy. At point L, lowest point, suppose half m VL square. This is the kinetic energy. Now as particle moves from L to H, then kinetic energy goes on decreasing and potential energy goes on increasing. But at point VH, again there is a conservation of energy. Therefore I will write here it is the sum of kinetic and potential. Therefore half m VH square plus mg, and h means this diameter. Yeah, this diameter here. This diameter d with the diameter which is height. Therefore I will write it mgh. Here you see m gets cancelled. We multiply by 2. Then VL square is equal to VH square plus 2GH. Now here we will put the values. That is VL means 10 square, VH means 6 square plus 2. We will write here 2 into 9.8 into H means I will write here 2GD diameter. H means diameter. I will correct here also mgd. Then I will write diameter directly. See here 100 is equal to 36 plus 2 into 9.8 into d. Now small d is equal to 100 minus 36 divided by 2 into 9.8. D is equal to 64 divided by 2 into 9.8. And if we calculate all these, we get here diameter is equal to, that is 3.26 meter. This is the diameter. Now the possible speeds, here you know, that is VH is equal to root GR, which is equal to root G 9.8 into R, half of this, that means 1.63, and it nearly comes out to be, that is nearly 16, nearly 4 meter per second. Now VL is equal to root 5 GR, means root 5 into VH. Therefore I will write here 4 root 5 meter per second. This is our example number 18. Now we will see example 19. Suppose example 19, I will read first. A metallic ring of mass 1 kg has moment of inertia 1 kg meter square. When rotating about one of its diameter, it is molten. It is molten and remolded into a thin uniform disc. Thin uniform disc of the same radius. How much will its moment of inertia when rotated about its own axis? See here. You have given first, that is a ring of mass 1 kg and moment of inertia 1 kg meter square. Now, when rotating about its diameter, ring is rotating about diameter, means I will write here ID. Ring is rotating about diameter. Now, if it is molten and remolded into thin uniform disc, now we will consider another body, disc of the same radius. Here you see, suppose R is the radius, then here also R is the radius. R is the radius. R is the radius. Now, they have asked how much will its moment of inertia when rotated about its own axis. I have used I asked, that is I is equal to what? About its own axis. We consider here own axis means transverse axis. Now here the moment of inertia of a ring rotating about its diameter can be given, that is I is equal to mr square upon 2. mr square upon 2. Here you see mass is same. Mass is same, which is equal to m, and radius is also same. Radius same, which is equal to r. And about its own axis, we have given I is equal to formula, you know, that is mr square upon 2. Mr square upon 2. And therefore, by direct logically, here you see, this is 1 kg meter square, and therefore I is equal to here also 1 kg meter square. Simple. This is the simple example. Now, we will see next one. Question number 20. See here. A big dumbbell is prepared by using a uniform rod of mass 60 gram and length 20 centimeter. Two identical solid spheres of mass 50 gram and radius 10 centimeter each are at the two ends of a rod. And we asked, calculate moment of inertia of the dumbbell when rotated about an axis passing through its center. See here, we have given a rod like this. This is the rod, suppose. This is the rod, thin uniform rod. Of mass m equal to 60 gram and length L is equal to 20 centimeter. See here, this length L. Now, two identical solid spheres of mass. See here, two identical solid spheres. These are the two identical solid spheres. Now, having mass 50 gram, m dash, suppose m dash is equal to 50 gram, and radius 10 centimeters. Here, r equal to 10 cm. R equal to 10 cm. Are at the two ends of rod, and when rotated about its own axis, what is the moment of inertia? This is our question. I equal to, see here. Here we consider two types of adjustment. Suppose the rod is like this. Rod is like this. Okay. And we consider two adjustments here. In question we have not given correctly. See here, this is the rod. Then in one case, these spheres we adjust like this. We adjust like this. Dumbbell can be formed. And another we consider, we adjust spheres like this. See here. In this case, there is one answer, and in this case, there is one answer. Here, suppose this is the first case, and this is the second case. In first case, we will consider total moment of inertia is sum of moment of inertia of these two, that is rod and these two spheres. And here also, same thing, total moment of inertia is sum of rod and these two spheres. Now, we will calculate for first case. Suppose mi of rod is equal to I1, means ml square upon 12. M means, I will write here 60, L square means 20 square, upon 12 means 5 into 400, that is 2000 gram cm square. And for these spheres, see here, mi of the sphere, one sphere, mi of one sphere is equal to about its own axis, that is diameter axis. We know this formula, that is 2 by 5 mr square. And about this parallel axis, see here, about this parallel axis, we use this same principle of parallel axis. Then mi of one sphere about given axis is equal to, I will write 2 by 5 mr square, this is IC, plus m, and see here, this 10 centimeter and this 10 centimeter, means total is 20 centimeter. I will write here m r1 square, means 2 by 5 into mass of the rod is, mass of the sphere is 50 into radius of the sphere is 10 square, plus again 50 is the mass of the sphere, and this distance is 20 square. Therefore here you see 10 means 10 square 100, 1000, I will write here 2000 directly, plus 50 into 400, okay, means I will write here 200, 2000 plus 20,000, means 22,000, and total due to two spheres, which is equal to 44,000, and therefore total mi is equal to this 2000 plus this 44,000. Answer comes out to be 46,000 gram cm square. This doesn't match with the answer in the book. Now we will see second case. Here, second case, mi of rod is same, is equal to I1 is equal to, I will write directly here, this much, 2000 gram cm square. Now for these two spheres, for one sphere mi is equal to same thing, 2 by 5 mr square, 2 by 5 mr square, and mi of one sphere, about given axis is equal to 2 by 5 mr square plus 2 by 5 m r2 square. I will write here, suppose 2 by 5 into 50 into 10 square, same thing it is, plus, and not 2 by 5 here, only mr2 square, mass is 50, and here we take this distance, that is 10 square. See here, means we will get here 2000 plus 5000 means 7000, and due to two spheres, double means 14,000, and total mi is equal to this 2000 and this 14, we get 16,000 gram cm square. In both cases, our answer doesn't matches with the answer in the book. This is one problem. This is the textbooks printed newly, so maybe problem. I have explained how dumbbell can be formed. In first case, we will form dumbbell like this. That means we stitch these ends of the sphere, one end of the spheres to the one end of the rod, and here we consider rod at the center. And in this case 16,000 gram cm square, and in this case 46,000 gram cm square. These two answers doesn't match with the answers in the book. Okay, but our methods are right and we have calculated clearly. Now we will see next example. Example number 21. Example number 21. A flywheel is to prepare earthenware pots is set into rotation at 100 rpm. It is in the form of a disc of mass 10 kg and radius 0.4 meter. A lump of clay to be taken equivalent to a particle of mass 1.6 kg falls on it and adheres to it at a certain distance x from the center. Calculate x if the wheel now rotates at 80 rpm. See here, we have given a wheel which is in the form of disc. Suppose this is the disc and it rotates about its axis. See here, suppose this is the axis with, we consider n1 equal to 100 rpm. Here you have given mass of disc m equal to 10 kg, r equal to 0.4 meter, radius. Now here we consider lump of clay. Suppose in this first case, suppose I1 is mi, and I1 is equal to, we can write here I1 is equal to disc, therefore I will write here m r square upon 2. This is the moment of inertia. Now a lump of clay, suppose we consider point, this is the clay whose mass is, suppose I will write m dash is equal to 1.6 kg, and this distance is x. Distance equal to x. Now distance equal to x. Now its moment of inertia, due the moment of inertia of this point mass, I will write suppose I dash is equal to, this is m dash x square, m dash x square, and total moment of inertia of the system is I2 is equal to I1 plus I dash, which is equal to, I will write mr square upon 2 plus m dash x square. This is I2, and here suppose n2 is equal to, we have given 80 rpm. Now we will use the law of conservation of momentum. That means I1 omega 1 is equal to I2 omega 2. I1 into 2 pi n1 is equal to I2 into 2 pi n2. This 2 pi gets cancelled. Then I1 n1 is equal to I2 n2, and we will write the values. M r square upon 2 into n1 is equal to m r square upon 2 plus m dash x square. This is the moment of inertia total, and n2. Now we will write the values. See here, mr square upon 2, m is 10, r means 0.4 square upon 2 into n1 means 100 is equal to, we will write mr square same thing, 10 into 0.4 square upon 2 plus m dash. M dash is here 1.6 into x square and n term is equal to 80. This one cancels. Now here 10 into 0.4 square, suppose I will write 5, here also 5, then 5 into 0.16 into 10 is equal to, in bracket, 5 into 0.16 plus 1.6 x square into 8. 5 into 0.6, I will write 0.8 into 10 is equal to 0.8 plus 1.6 x square into 8. Now 0.8 plus 1.6 x square is equal to, this 8 to this side, 0.8 upon 8 into 10 means 0.8 plus 1.6 x square is equal to 0.1 into 10 means 0.8 plus 1.6 x square is equal to 1, and 1.6 x square is equal to 1 upon, sorry, 1 minus 0.8 means 1.6 x square is equal to 0.2. And if we solve, see here, x square is equal to 0.2 divided by 1.6 means I will write here 20 divided by 0.2 divided by 1.6, and we calculate all these, then we get here x is equal to, I have calculated x is equal to 0.33 meter. This is all about. Now one example is remain 22, and some key points about CET we will see in the next lecture.